Unraveling the Mysteries of Light, from Ancient Beliefs to Einstein's Relativity. In this episode, the journey of a photon, from its origins in the Big Bang to its collision with a telescope near Earth, is presented for the viewers. From the early philosophers to modern-day physicists, the properties of light and its behavior have been studied and understood in new ways, leading to a deeper understanding of the universe we live in. The history of our understanding of light begins with the ancient Greeks, who wondered whether light emanated from the eyes, and Islamic scientists who discovered the properties of light such as reflection and magnification. The scientific revolution brought new ideas from Christian Huygens, who believed light was a wave, and Robert Hooke, who thought it was made of tiny particles. Also, Isaac Newton defended the particle-like or corpuscular theory of light. It wasn't until the 19th century that the wave theory of light was favored again, paving the way for modern-day quantum mechanics. James Clerk Maxwell's equations showed that light is a self-propagating electromagnetic wave generated by oscillations of electric charges or electrons. Maxwell's equations showed no limitation on the wavelength of electromagnetic waves, which implies there are both visible and invisible light. Albert Einstein challenged Maxwell's idea of light as a wave, proposing that light also acts like a particle, which was later confirmed by experiments. Arthur Compton's experiment showed that X-rays and electrons interact like colliding billiard balls, suggesting that light is a particle. Louis de Broglie suggested that light was neither a particle nor a wave, but something that exhibited properties of both, which was proven in experiments and earned him the Nobel Prize. Richard Feynman, a legendary physicist, revolutionized the way physicists thought about the quantum world with his introduction of the Feynman diagram, which describes all possible interactions in quantum mechanics. Feynman's work on the electromagnetic force showed that two electrons interact through the exchange of a photon, and this is a quantum phenomenon. Einstein's theory of special relativity ended the idea of the ether, and proved that the speed of light was the universal absolute and invariant. For photons, time is non-existent, and their experience of space is different from particles with mass. Time is definitively relative, as numerous experiments have shown, and this means that space and time themselves become flexible and rubbery to accommodate the consistency of the speed of light. Light feels the existence of gravity, and its path is deflected by the presence of mass, as predicted by Newton's claim of 2 centuries prior. For photons, no matter how far they travel across the universe, not a single instant of time will take by. The space-time distance between the creation and destruction of a photon is exactly 0, and the photon itself notices nothing. See The Full History of the Universe YouTube episode, published on Friday, February 24, 2023, by Spanish brothers David and Pete Kelly.